Hi everyone, I hope you're doing well today. Yesterday we talked about relations and functions, and we defined a relation, we defined a function, and we determined how we can tell whether a relation is a function or not based off of collection of sets. And now we're going to look at a relation that is on a graph, and we're going to determine whether a relation is a function or not based off its graph. So, if we want to determine if a relation is a function or not, we do something called the vertical line test. The vertical line test says that a relation is a function if you draw a vertical line through its graph and it passes through only one point. So, let's take a look at graph number 1. Graph number 1 is the graph of y equals x, which is a relation. That means if I input a value, the output is the same value. So if I input 5, I output 5. And this is what the graph looks like. So now let's draw a vertical line on this graph. If I draw a vertical line, it crosses this graph at exactly one point. So far, it's passing the vertical line test. It's crossing at exactly one point. In fact, if I draw a vertical line anywhere on this graph, that vertical line crosses at only one point. So this is a function. Okay, so let's take a look at graph number 2. Graph number 2 is an ellipse. So let's determine if this is a function or not. Now, if I draw a vertical line outside of the ellipse, it doesn't go through any points, and that's okay. If it doesn't go through any points, that's still passing the vertical line test. Now, if I draw a vertical line at the edge of the ellipse, it crosses at exactly one point. So that's okay too. But I encounter a problem when I draw a vertical line across the middle of the ellipse, and it crosses at 2 points. The vertical line test says it can only cross through one point. Since it crosses through 2 points, this fails the vertical line test, and this is not a function. So now we're going to look at whether a function is discrete or continuous. So let's define each of those. A discrete function is a function with distinct and separate values that are not connected. In other words, the values are separate points. So a discrete function is a collection of separated points or values that are not connected. Now, a continuous function is a function in which contains values that form a single unbroken line or curve. So basically, if you can draw the function from beginning to end without lifting your pencil, it is continuous. So discrete, separated and not connected. Continuous, they form a single unbroken line. So let's take a look at graph number 3. Graph number 3 has the values -7, 1, 1, 0, 5, -7, 7, 5, 8, 2, and 10, 8. So now let's determine if this is a function or not. If I draw a vertical line anywhere on this graph, it only crosses through one point. So this is a function. Now, is this discrete or is this continuous? As you can see, none of the points are connected to another point. In fact, we would need all of the points to be connected in order for this to be continuous. But since they are not connected, this is a discrete function. So now, let's determine what the domain and range is here. So the domain is going to be the collection of the inputs. So my domain is going to be the set that contains -7, 1, 5, 7, 8, and 10. Those are all my x values or my inputs. Now the range is going to be the set that contains my outputs or my y values. So I would have -7, 0, 1, 2, 5, and 8. So now we're going to take a look at graph number 4. And is this a function? So let's draw a vertical line. And it only crosses through one point. Let's draw a vertical line somewhere else. It only crosses one point. This is a function. Now, is it discrete or is it continuous? We have a beginning and it connects all the way to the end in a continuous line. So this is continuous. Now, what is the domain and what is the range? So the domain is all of my x values. There is a continuous line starting at -5 that continues until we get to 4. So my domain starts at -5 and goes to +4. Now, it's including -5 because I have a closed dot at -5. So at the beginning of -5, I would have a bracket, and at the end of 4, I would also have a bracket. This means that my function starts at -5 for my x values and ends at +4 for my x values. Now this is how you would write it in something called interval notation. Bracket -5, comma 4 bracket. Another way to write it is in set notation. In set notation, I would put a brace, and then I would say x and a vertical line. The vertical line means such that, and then I would write this as an inequality. The inequality would start at -5, and then I would say less than or equal to x, and I would say less than or equal to 4, and I would close with a brace. This is another way of saying that x are the values that are between and including -5 and 4. So now let's look at the range. If we look at the bottommost value, because we're looking at the y values, the bottommost value is -4, and the topmost value is +4. So to look at the domain, we look at left to right values. To look at the range, we look at bottom to top values. So the range in interval notation is going to be bracket -4, comma 4, bracket, because we're starting at -4 at the bottom and we're going to +4 at the top. Now, in set notation, this would be brace y, because this is the output, such that -4 is less than or equal to y is less than or equal to 4. And then we would close the brace. Okay, let's take a look at graph number 5 now. This is the graph of y equals 3/2 sine of x. Okay, this is a special function from trigonometry, and it is a function. If I draw a vertical line, it crosses at only one point. In fact, anywhere I draw a vertical line, it will only cross one point. So this is a function. So now, is this discrete or is this continuous? It is connected. So this is continuous. So now, let's state the domain and range. The domain, if we look, it starts all the way at the end of the graph. In fact, it's going to keep going beyond the graph to the left and beyond the graph to the right. So this goes all the way to -infinity. So the domain is going to start at parentheses, -infinity, comma, +infinity. And then in set notation, that would be brace x such that x is all real numbers. So now let's look at the range. If we look at the range, the lowest value is at -1. The highest value is at +1. So the range in interval notation is bracket -1, comma 1, bracket. And in set notation, it would be a brace y such that -1 is less than or equal to y is less than or equal to 1, close brace. So now we're going to look at graph number 6, and is this a function or not? As we can see, all of the points are nice and separated. So this lets us know this is discrete. Okay, so we know this is discrete. And if we draw a vertical line anywhere, it doesn't cross 2 points. None of the x values repeat. So now we can state the domain and the range. So this is a discrete function, and the domain is -7, -5, 2, 3, and 4. Now the range is going to be the set that contains -5, -3, -1, 2, and 4. The domain is all my x values. The range is all my y values. Okay, so let's take a look at graph number 7. Is this a function? So let's draw a vertical line in a couple of places here, and each time it only crosses at 1 point. So this is a function. Now, if we look at where it begins to where it ends, it is connected between all of those points. It's a single unbroken line. So this is continuous. So now let's look at the domain and the range. If we look at the domain, on the left side, the first x value is -4. So we would put bracket -4, comma, now we read it to the right. At the rightmost value, it's +4. So we have a domain of bracket -4, comma 4, bracket. So now in set notation, it would be brace x such that -4 is less than or equal to x is less than or equal to 4. So now the range. The bottommost point for the y value is a y value of -4. So our range starts in interval notation at bracket -4, comma. Now we go to the highest value. The highest value is a y value of +4. So we would put +4 and close bracket. So our range is bracket -4, comma 4, bracket in interval notation. In set notation, it would be brace y such that -4 is less than or equal to y is less than or equal to 4. Well, I hope you enjoyed part 2 of relations and functions. Hopefully you know how the vertical line test works. You know whether a function is discrete or continuous, and know how to state their domain and range in both interval notation and set notation. If you have any questions, feel free to message your teacher, and have a great day.